Hey folks, this is Matan. I'm the co-founder and CEO of Rapido Technologies. Today, I want to talk to you a little bit about relational databases in the cloud, the challenges that are coming with the new era of microservices and multi-tenant architectures, and why essentially in the cloud world, managing relational database is broken. I'm grateful to be a gold sponsor of Conf42. We're excited to be here and to be part of your community, at least for the upcoming year, and learn more from your insights about the DevOps, SRE, cloud engineering aspect of databases, and hopefully to bring value to multiple folks from this community using the tools of Rapido. So let's dive in. Managing relational databases in the cloud is broken. And why do we say that? The cloud has introduced companies with new challenges related to managing auto-scalable applications. Kubernetes, auto-scaling groups have all introduced dramatic flexibility, but severe challenges in any shared everything architecture like relational databases. So in the end of the day, your application is able to scale automatically by 1000x, but your database is a one monolithic piece that is very, very hard to manage. So essentially, your databases and your applications in the cloud has evolved and changed dramatically, but the tools that are allowing the DBMS itself has not changed at all. And this is why we believe that the entire way companies are managing relational databases in the cloud today is broken and introducing a lot of challenges related to observability, SLA, resiliency, and costs. The trend, and I'm going to skip the previous slide, but the trend was that in the past, companies managed a small fleet of databases, right? So on-prem, when you have few monolithic applications, it is relatively easy to manage your database. You have a full-blown DBA team that know exactly what they do on the databases. The changes in the scale are not severe. So it's not thousands of percents. It's 10, 12, 15%. So sizing for the peak is not hard and it's not expensive. And due to these factors, managing performance and tackling issues was not hard as it is today, right? Mean time to detect, mean time to resolve databases issues was not high back in the days when you had a full-blown DBA team, when you had monitoring systems that monitoring 5 to 10 databases, with the disadvantages, of course, of living in a monolithic world in terms of time to market for new applications, in terms of flexibility, launching new services. Living in that world for databases side of things was not too bad, besides the Oracle or SQL Server license that you had to pay. In today's world, with microservices, micro applications, in many cases, thousands of micro applications, managing tenants became great opportunity to accelerate time to market for new applications, new features, substantial flexibility, right? Like building and deploying new features became so fast that we deploy new features to our SaaS applications, in many cases, every day. And we all rely on open source databases like MySQL, Postgres, and it became actually a great world for managing applications. But alongside the improvements and the value that we gained in the auto-scalable world, in the cloud native world, a lot of changes came to teams managing RDS in the cloud. Or relational databases in the cloud. When you manage a fleet of databases, it is very hard to reduce downtime and improve performance, right? So tracking 5,000 databases and understanding where exactly your CPU is close to the edge, it's not easy, right? gain visibility across all databases in a single dashboard. This is something that many companies are seeking to gain, but using the current tools like RDS Performance Insights or Datadog is not easy. It's not easy to see that level of visibility across a fleet of databases. Finding and addressing slow queries across your entire fleet. So this is hard. And due to that, we see mounting costs, and many companies are just pouring more and more money on databases in order to reduce SLA and resiliency issues. And this really makes companies becoming, so if you think about a tool, a native tool in AWS, RDS Performance Insights, right? It gives you visibility only to one DB instance. And when you look on one DB instance, when managing a fleet of 5,000 databases, you are by definition reactive and not proactive, right? And one of the things we always want to do when we manage such an important asset like our databases is to be able to be proactive. So even when you can find the root cause, when you have a fleet of databases, what can you do about it, right? Sometimes you have legacy code, you have you have big R&D organization. What can you do as an operational team when you see a CPU or IO spikes or a problematic query? In the end of the day, the only thing you can do is to ship that to your dev team, right? So what we believe the ideal tool will have, right? Like what are the properties of the ideal tool? So the three pillars of modern database management tool will be observability. So improving observability across thousands of instances, improving resiliency with no code changes, and maintaining a sane cost on your database, right? So if you will look on every AWS or Google Cloud bill, RDS and Cloud SQL will typically be the second or the third line item. So observability, resiliency, and cost are the three legs of the stool when managing a relational databases in the cloud. And missing any of them will not get you the results you need. Now, let's dive a bit further into observability, right? So what is it exactly that we miss today in today's world in the existing tools? So first, it's no longer effective to have a look at each database individually, right? We need a solution that looks across all of our databases and pulls all the metric data into a single consolidated view, right? So essentially, you need to see what are my slowest queries across my entire fleet. Which DBs we want to see the top CPU or the highest CPU load right now across my entire fleet. We want to see the highest memory IO consumption across my entire fleet. We want to set alerts and get notified if certain thresholds are hit. We want to see whether we are running out of database connections, right? So DB connections are limited. And when you manage 500 or 5,000 databases, being able to track where do I have shortage on connections is very hard. So this is another thing we want to manage. We want to get visibility into table locks and deadlocks across 5,000 databases, right? So these capabilities are something you must have when managing a SaaS application, when managing databases for a SaaS application. The second pillar will be resiliency. So the tool that you use must be able to put guardrails in place to protect the databases from those type of issues cause outage, right? Like when your CPU spikes, right, to 100%. You got to be able to protect your database from these spikes. When bad queries are hitting your database, you got to be able to respond fast and rewrite those queries in transit. When bad code is sending too many queries or too many requests, the same query over and over to your database, you got to be able to throttle that or to cache that. When you access idle connections, you get ran out of connections. You get ran out of availability, right? So you got to be able to protect your database from shortage of connections. These capabilities must be an integral part of your database fleet, right? Of managing your databases in the cloud. Now, on top of that, you got to be able to not pour tons of money on your database to do that, right? So you got to be able to make sure that your CPU and IO costs are not going through the roof. You got to have a capacity planned that will not be based on your CPU spikes. You got to be able to protect your database from CPU spikes that will kill your application. So again, resiliency, observability, and maintaining low costs or same cost in the database are what you must have when managing fleet of databases. So this is, guys, when I introduce Rapido to you. So Rapido is a platform that allows company. It is fully deployed in your VPC. It allows companies with large fleet of databases to manage manage visibility, observability. So as you can see, Rapido Scout, our observability platform, will connect to all your Postgres and MySQL databases and start aggregating data about their processing infrastructure metrics like CPU, IO, memory, and consolidate them in one pane of glass. On top of that, we have Cortex, which is our automation layer that allows companies to offload repetitive queries from their database via a proxy and also via the connections that we manage. So you could deploy caching, throttling, query rewrite, a lot of capabilities in one tool, in one platform. So let's now move to a live demo of Rapido and see the platform in action. So guys, this is the Rapido console, and as you can see, our master dashboard will get you visibility to the most pressing issues across your entire fleet of databases. Let me move to 48 hours so we could have more data. And as you can see, these are the most pressing issues across my entire database fleet in the last 48 hours, right? So we can see the top or the average query runtime across my entire fleet, right? So the average query runtime is 12 seconds, but when I drill down, I can see that I have some queries with average runtime of 120 seconds or 2 minutes, and I have some queries with sub-second or second runtime. And again, every line item that you see here is a query on a database on a DB instance. On top of that, you will be able to see the top CPU consumers across your entire fleet. You will be able to see shortage on connections. You will be able to see locks and deadlocks across your entire fleet. And every column that you see, I just drill down to my deadlocks or to my locks view. And if I group by, we love the group by capability, right? So if I group by, you can easily see that my Postgres database is by far the most suffering entity from locks across my entire fleet. So using Rapido, you can actually gain visibility to Postgres and MySQL instances in one pane of glass, right? So my Postgres database is the first, all the others are MySQL database. Now I can expand that and I can see whether I'm facing a transaction lock or metadata lock. I can aggregate by the current statement. So I can see that there are two statements. There is one update and one select on my Postgres database that is generating a lot of locks. At this point, I can use Rapido or engineering tools to fix that locking, right? Now, as you can see here, we had a CPU reduction on multiple databases, but we have one database here that is running on 99 to 100 CPU utilization most of the time, right? Now, at this point, guys, I can move to the real-time view of Rapido. And as I mentioned, here you can actually see a flat list of all your Postgres and MySQL databases in one pane of glass. I can group by again and see that I have one Postgres instance and 11 MySQL instances. And we can see that my demo database here, it's a MySQL 8 database, DB, it's Graviton machine, large, with 100% CPU and shortage of database connections, right? So I have 250 connections out of 250 utilized. And I have a query of 5 minutes on that database. Now, clicking on that will allow me to drill down and to see what is happening in real time on that particular database, right? So you can see that we have a very repetitive query here, but the great part is that you can actually see how the issue started to compound. So looking 15 minutes ago, and grouping by, again, we love the group by capability here in Rapido, grouping by showing me that the SQL calc found rows function from the parents table ran 4 times in parallel. Moving a bit forward in time, we can see that it spiked to 112, and a bit further, we are looking at 230. And if I go back to the live view, you can actually see that currently we have 237 queries running right now with that specific syntax. Now, using Rapido, I can actually do stuff, right? Not only gaining visibility, but also pull the trigger and kill the query that is generating the spike. I know that killing a query is something that you will probably think twice before you pull the trigger on. But when you have the ability to do that, using Rapido will actually be a lifesaver because you could actually remediate the issue on the spot. Now, as you can see, I'm killing the query, but my application throw it back again to the database. So this is not a very useful solution to kill the query right there on the spot. At this point, guys, I want to move to the automation field of Rapido. Let me quickly refresh my page here. I'm gonna go ahead and log in again to my application. Let's give it a sec. Yeah, I guess I loaded my database too much. There you are. Going now to the automation field will show me the vast amount of rules that you can deploy using Rapido. So I can go ahead and cache query. So using Rapido, you could essentially deploy caching using table-based invalidation. So I did not copy the query. Let me go back to Rapido and copy the query again. So by the way, as you can see here, it dropped and I lost connection to the database. So this is why I'm not having data here. But as you can see, it started like compounding again. And now the query amount is growing rapidly, right? So at this point, I just copied the query name. I'm going back to my caching rules, and I can go ahead and deploy a cache rule, right? A cache rule can be based on a query or a table. I can cache an entire table or a query. In this case, I would probably want to cache this query. I'm going to choose a query, and look at this. Without us, we are currently the only solution, or we enable you to do something that you were unable to do without Rapido as DevOps or SRE teams, and it's to deploy a caching rule on your own with no business consequences, right? Because if you use table-based invalidation, we will actually make sure that the cache data will always be coherent with your database itself, right? So if I'm going to go ahead and save that, now I have a query cache that will essentially offload that query. Now, that probably won't be the great solution or the best solution for this use case, because this query is using current date and it essentially changes every nanosecond, right? So at this point, I'm moving to Scout rules. In Scout rules, I've already prepared a rule that throttle this query to 2. So it will allow this SQL calc found rows to run only 2 times in parallel. And look at this, right? I'm using here a wildcard on the limit, right? So it's a flat line. Think about it as a flat line. I'm using a wildcard here that essentially limits that query to run only 2 times in parallel. Now, I'm going back to my MySQL. It remembers the configuration I had. And as you can see, the problem compounds again. But at this point, guys, I'm going to go ahead and pull the trigger, killing that process. And within a few seconds, you will see that it's gone. And and it's not going to spike again, right? So essentially maintaining a throttling rule will allow me, and you can already see it starting, right? So now I have only 2 instances of the SQL calc found rows, right? So my application keeps throwing the query to the database, but now Rapido will allow only 2 execution in parallel, right? So you can see it right there, going back from 75 to 46 to 2, right? So guys, this is what Rapydo is all about. I hope this session was interesting. I would love to dive further and show you Scout rules and alert rules. So using Rapydo, you can essentially maintain a low footprint of connections. You can maintain policies that will make your database sane and not spiky. Going back to the presentation, feel free to drop me an email at matan@rapido.io. I would love to extend the conversation and discussion on relational databases in the cloud. So even if it's not related to Rapido, I'm down with any discussion about databases. And I really hope to meet you guys face to face soon. So have a great day and take care. Bye-bye.